divide fractions. And the notion of dividing fractions involves reciprocals, like we talked about last time. What you're going to learn is that when you divide fractions, it's really not that bad. You don't need to find the LCD like you do when you add and subtract. In fact, when you divide fractions, it's all on the wrist. It's just all on the wrist. You'll see what I mean. Before we talk about that, though, let's review the reciprocal idea. Remember what the definition is? A reciprocal of a number. What do you multiply this number by to get 1? The easier way to think of it, though, is just flipping it over, right? That's the way it works. When you multiply negative 1 over 3 times negative 3 over 1, it equals 1. It equals 3 over 3, which is 1, right? What's reciprocals of 7 or 7 over 1? Why, it's 1 over 7, because when you multiply them together, you get 1. What's reciprocal of C over D? We have to assume D is not 0, of course. The reciprocal of C over D would be D over C, wouldn't it? There you go. Okay, so here we go. Here's the definition of division. We'll come back to this in the next problem set and talk about why it works. But let's just focus on what it's saying and look at some examples, okay? When you divide a first fraction by a second fraction, you change it into a multiplication problem. You keep the first fraction the same and you multiply by the reciprocal of the second. You see? First fraction divided by the second is equal to the first fraction times the reciprocal of the second. And it's really important that you take the reciprocal of the second, not the first. Keep the first fraction the same. So for this one, here's your division. So you keep the first fraction the same and you multiply by the reciprocal of this. Again, we are going to come back and talk about why this works later, but let's just focus on what it's saying for now. So you multiply by the reciprocal. The reciprocal would be 12 over negative 20, but I also move the negative up to the top. It's kind of a nice little thing to do. That's legal, right? Then you just start to factor. Now when you factor this, let's see, the 3's cancel. Actually, it turns out, check this on your own, but I believe everything cancels except the negative 1. So that's your answer, negative 1. Hit the pause button and make sure of that. Make sure that I did that one right. On this one, what's the trick on this one? How would you divide negative 12 by 5 6? Why, you'd think of it as negative 12 over 1, of course. And then you flip over the second one, 5 6, it becomes a multiplication problem, and you multiply by 6/5, and then we start to factor, but I don't think anything cancels here. All you have on the bottom is really a 5, and I don't see any 5s on the top, so that's why your answer is negative 72 over 5. Let's do some more. This one, so if you were to change this to a multiplication problem, you flip this over, so it would be negative 12 over 5x times 20xy over negative 30, but I think I actually move the negative up again on the top. I just like to do that. Now when I start to factor this, you see how there's a negative 1 that's multiplying here and here, so don't the negatives cancel? The negative 1, the factors of negative 1 are going to multiply to give a 1, so when I factor this, I'm just going to drop that. Alright, you can do that. Start to factor. 12 is 2 times 2 times 3, 20 is 2 times 2 times 5, x and a y at the end here, 5x, 5. I like to put the x on the end like that. And then 30 is 5 times 2 times 3. Check this on your own. When I canceled everything, I got everything cancels except there's a 5 left on the bottom and an 8y on the top. But verify that I did that right, okay? Alright, let's do a couple more, then I'll give you some to try. This one, what's the trick here? The trick here is, think of this as 24 over 1, right? So when you change it to a multiplication problem, it becomes 1 over 24. Then you just start to factor everything. And when I simplify it, again, check me on that, I believe everything cancels except everything cancels from the top. You have a 1 left, remember? When everything cancels, you still have a 1 there. And you have a 10x on the bottom. Okay, look at the difference between these two problems here. They look the same, but on the first one, on the first one there's no parentheses. On the second one, there's parentheses around the second division problem, the second division. So on the first one, the order of operations says we should technically do this division first, right? Okay, so what we do is we flip this over and say times 3/2. It's okay to change the way it looks. Even though we're going to do this operation before this one, it would be okay to flip this one over too. In fact, you could have flipped them both over at the same step. Why is that a good idea? Because look, now they're all multiplication. What's nice about multiplication? Multiplication, you can multiply in any order, you can move them around, so you can start to go factor crazy here. When you factor everything on the top and bottom, I think everything cancels from the bottom, I think you have 2 3s left on top. Again, check me on that. So that equals 9. Now, in the second one, it's a little more complicated. You must do this division first. So let's work inside these parentheses. I flipped over the second one and called it times 27 over 4, right? Now, I'm going to go ahead and try to reduce this a little bit before I flip it over. I'm not sure exactly what to flip, actually. So let me just write it as a single fraction that's reduced. Then I'll flip it over, okay? So when you factor everything on the top, it looks like a 3 and a 2 cancel. So when all the dust settles here, you just have a 9 halves inside the parentheses. Now I'm going to flip it over. And you get 8 nines times 2 nines. It looks like nothing cancels. You see why I can tell that nothing's going to cancel? Because the bottom is just a bunch of 3s, the top is just a bunch of 2s, so that's why your answer is 16 over 81. Okay, let's do a little more here. Recall when you divide, there's 2 ways to write a division problem, right? 4 divided by 9 is the same as 4 over 9. Instead of the division sign, you could write the division bar. Okay, well, with dividing fractions, this is just another way to write the same rule. When you have a fraction divided by another one, the top fraction divided by the bottom one, you could write that as a multiplication. You keep the top one the same, or the first one the same, and you multiply it by the reciprocal of the bottom one, or the second one, right? So that this is just the same rule, it's just written differently. A over b divided by c over d equals a over b times the reciprocal of c over d, which is d over c. Same rule, just written differently. You got to get used to seeing problems in different formats, right? Here we go. On this one, see, you have 3/4 divided by 6/10 over 6/10. So you could write it like this: 3/4 times the reciprocal of 6/10, which would be 10/6. You start to go factor crazy, and you can cancel a 3 and a 2. I get 5/4. Of course, there's some sneaky stuff too. This one is a little bit sneaky. You see, it's 5/7 over 10. So you got to really recognize where the major division bar is. It's right here. So this is really 5/7 divided by 10 over 1. Now you know what to do, though. It's 5/7 times 1/10. You can factor, you can cancel a 5, and you get 1/7. That's your answer. All right, here we go. So why don't you hit the pause button and try these. We'll go over these in just a minute. Whoops. There. Now you can see it. Okay, here we go. The first one, division problem, we're going to keep the first one the same, multiply by the reciprocal of the second, right? We start to factor everything. A lot of factoring going on here. We're gonna, did you get 4? That's what you should have gotten. That's what I got, at least. I got 4 on that first one, when everything cancels. On the second one, this is kind of tricky. See those parentheses around there? Think of this as the numerator and this is the denominator. This is one of those times where it might be easier to convert it to this notation, because this looks like something that you've seen back, way back in problem set 28. How would you simplify this? Well, it's a fraction. You would reduce it. How do you reduce fractions? You factor. You factor the top using the distributive law. Some of you might feel more comfortable to change it to additive form before you factor the 3 out, but either way you get to here. And then the 3's form a factor of 1. You can take away the factor of 1. That's why your answer is x minus 2. Okay, so sometimes if you got to look at it just right, it's not that bad. It's true about everything, isn't it? All right, this one, did you think of this as negative 3 over 1? Okay, and then you flip over the second one, right? So you get this, then you start to factor. It's nice to pull off that factor of negative 1. I like to do that. So what cancels? I think just an m cancels, right? So you get negative 15 halves. That's what I get. Last one. This is 6/10 divided by 3/5. So you have to multiply by the reciprocal of this second one. So you get this, factor everything. Let's see, you can cancel a 3. Looks like you can cancel everything, right? And in 1. Wouldn't it be nice if every problem was that simple and every answer was 1? Unfortunately, it's not. All right, we'll see you next time. Bye-bye.